Hello, my name is Carmel Hauck, T00701793. This is part 2 of assignment 5. I am going to explain how the muscles of the eye work. On this diagram, I'm going to be specifically talking about the lens, the suspensory ligaments, and the ciliary muscles. So the eye muscles use the process of accommodation to orient the lens and change its shape to see near and far. So when the muscles of the ciliary body relax, the suspensory ligaments attached to the lens pull it into a flattened shape that allows distant vision. So essentially we're seeing this being pulled up and flattened so that we can see far away. And then when the muscles of the ciliary body contract again, that takes tension off of the suspensory ligaments, which allows the lens to go back to its natural, more rounded shape to see close-up. So the close-up vision requires the ciliary body muscle contraction to see close-up. The next form of muscles in the eye that we're going to talk about are the muscular diaphragm of the iris. So it controls the amount of light that enters the eye and changes the pupil size. So I didn't find one that I really liked, so I just doodled one, so excuse the doodles. Essentially, in the middle here, I have a normal eye. The iris is controlled by two sets of smooth muscle fibers, so the radial and the circular. So I'm going to draw them here quick for you. So on the normal eye, we have radial and we have circular. So the circular muscles are in blue, the radial muscles are in green. Now, when we are looking at bright light, our pupil reduces in size as the circular muscles of the iris contract. So our circular muscles around here are contracting. So they go around like this and contract. And this makes the radial muscles change shape like that. So that is when our pupil is small, it constricts in. And then opposite, when we see in dim light, the pupil is wide open as the radial muscles of the iris contract. So it is the opposite. And we have a very small and our movement, our muscles are going out this way, like that. So that is how the iris muscles work. We have the circular muscles and the radial muscles working kind of like a wheel. So next I'm going to talk about nociception. So nociception is the process of feeling pain. Pain receptors are also called nociceptors. There are 4 stages, starting with transduction. So this is at the site of pain. So if I stub my toe, transduction starts at the site of my toe, and it converts it into nerve impulses. The next stage is transmission. Transmission moves those nerve impulses up the nerve fibers towards the spinal cord. So again, if I kick my toe, moves up my leg towards my spine, that is transmission. Next, we have modulation. So this is the process in the spinal cord where the nerve impulse is actually altered. So it can dampen it or it can enhance it to kind of change that information before it passes to the brain. So this is where NSAIDs and other drugs kick in, where they can kind of change that pain before it gets to our brain and dull it. And then the final one is perception. So this is the conscious perception in our brain, in the cerebral cortex, where pain is registered. It also takes into account kind of our emotions too. So did we stub the toe in our kitchen, or did we stub our toe running away from a murderer? Kind of takes that into effect too, how much we will react to the pain. What I found really interesting about that is that general anesthetic only blocks the last one, so only blocks perception. So when a pet is being spayed, it feels the first three processes, it just blocks it at the brain. So this is why we use like post-op, or not post-op, well, before we even wake them up, we use Medicam or Hydro to kind of start that pain management process before they even wake up, so that when they wake up, it's not all the pain at once. And this leads to kind of identifying the key factors of pain. It's very, very important for us to kind of know what the subtle signs of pain are, because animals are so good at hiding their pain. It's literally a survival instinct for them. If they appear weak in the wild, they're more likely to get picked off by predators. So they hide it. They don't show pain very well, which makes it hard because they cannot talk to us and tell us that they're painful and where it hurts, which makes us have to kind of pay attention to those subtle signs of pain that we can recognize. Physically, during an exam, we can see some obvious signs of pain. They might be limping, they might have an increased heart rate if we're pressing on a certain area, they might wince or whine or even yelp out if a painful area is touched. But again, if they're not doing that, it doesn't necessarily mean that they're not painful. So we can then look at the more subtle forms of pain. So they might not want to eat, they might not be grooming, they might be over grooming, they might be kind of not as playful, distancing themselves, not wanting to do their normal routine, not themselves essentially. This is a big thing with cats, especially because they hide pain so well that you might not know they're hurt or sick or injured until it's way, way, way progressed. So changing and paying attention to those subtle signs, very, very important for us as technicians.